Hey everyone, in this video we are going to solve a question from the LeetCode. The name of the question is unique path second. This is a variation of the unique paths. So if you are someone who is directly solving this question, I would highly suggest you to solve the unique path first and then solve this question. So what we have in the question, we are given an n cross m matrix where n are the number of the rows and m are the number of the column, and in that matrix there is a robot that is standing at the top left corner and he have to reach to the bottom right corner. And in some cell of the matrix there are some stone placed, and at each moment of the time the robot can either take a right move or a left or a down move. So in the end we have to return the total possible ways through which the robot can move from the top left corner to the bottom right corner, and those path will not contain any stone in the cell. Okay, so in this video basically I will be using the recursion plus memorization approach, and in my later video I will try to solve this question using the tabular method. Okay, so first of all if we look carefully what we have in the question, we are given a matrix. Our robot is standing at the top left corner and he have to reach to the bottom right corner. At each moment of the time we have two possible ways. Either the robot can move to right or either the robot can move to the down. So can I say the answer of this whole matrix will be equal to the answer of, if the matrix will be this much, if the matrix was only this much, means 2 columns 3 rows, or 2 rows 3 column. Okay, so can I say, if I get the answer of this matrix that contain only the answer of the that contain only the 2 column and the 3 rows, or sorry, not or and the matrix which contain only the 2 rows and 3 column, if I get the answer of these two matrix, then I will simply add them and this will give me the result of our complete matrix. Why I am taking So first of all, why I am taking the answer of the this matrix, these two matrix, because this matrix will give me the result when I move right. Okay, and this down matrix give me the result when I move down. Okay, so if you understand till now, the question is pretty much solved. Now what can I do? I can again further divide this matrix into sub matrix. Now suppose robot is standing at this position. Can I say, give me the result of this matrix, this only matrix, and give me the result of this only matrix, and then I will add them and I will get the result of this matrix, this complete whole matrix. Give me the result of matrix that contain only the 1 column 3 rows, and give me the result of the matrix that contain 2 rows and 3 columns. And similarly I will divide this matrix. So this is the concept of the recursion. We divide a bigger problem into smaller sub problem and compute the sub problem and use the result of sub problem to get the result of our actual big problem. So that is what we are doing in this question. So suppose this is our function solve. Our robot is standing at the 0,0 index and this is the this is our matrix. In one move I can move either down or I can move right. When I move down, what will happen? The number of the row will be increased, the index of the row will be increased, but the column will be same. So this is our row and this is our column. So the row will increase, so it will be 1, but the column will remain same. Great. Solve. And when I move right, the index of the column will increase, but the row will same. And again this will further divide into the sub problem. I will be moving in the down direction, I will be moving in the right direction, down direction, right direction. When I move in the down direction from here, what will happen? The number of the row will increase, but column will remain same. And when I move from right from this cell, the column will increase, but the row will remain same. So I can divide this problem into a smaller sub problem, and there will be one base case. From that base case we will be returning our result. So what will be that base case? So the base case will be when we reach to the last index, or I can say the bottom right corner of the matrix, when the row will become to n minus 1 and column will become to the m minus 1. Row will become to the total number of the rows, and the column index will become to the total number of the column. In that case I can simply return 1, and after computing this result I will simply adding this thing. So let me just code it out. And there is before coding there is one more condition, that before moving to any cell we have to check whether that cell contain an empty space or a rock. In case there is a rock in that cell, we cannot move, we have to skip that cell. Okay, so I will be writing a recursive function and solve. There will be two indexes, int I, which will represent are the row index, and the int j, which represent the column index. Vector and grid. When I reach to the bottom right corner, that is our base case. So before writing that condition, int n will be the total number of the rows, int m will be the total number of the column, n minus 1 and j equal to m minus 1, means that we have reached to the bottom right corner of the matrix. In that case we have to simply return 1. And else what we can do, we can either move right or either we can move left. So for moving left or right, I am creating two array that will help me to compute the new index, basically 0, 1 int y will be 1, 0. For int k equal to 0, k less than 2, k plus plus, int nx will represent our new index. So the new index will be when x plus k and y equal to j plus yk. Okay, so this code will return us the new index. So let me show you how. There are two index 0, 1. There are two array. One is the x that contains the 0, 1. One is the y that contains 1, 0. And suppose we are starting at the 1, 0 index, and if we move right, the column will increase 1, 1. If we move down, the row index will be increased 2, 0. So what we are doing in our logic, we are simply adding these values that are present in this array with our actual index. So currently value I plus this x comma k can be 0 or 1. Suppose the value of the k is 0, so I plus k and j plus yk. The value of the I is the 1, the value of the j is 0, and suppose the k is 0 in this case. So I plus 0 given 1, and j plus k, j plus 1, that is 0 plus 1, it will give me the result 1 1. So in that case it means that I have moved right. And when k become 1, 1 plus x of k, x of k is now 1, so it will become 2, and j plus y of k, is 0. 2 plus 0, it become 2 comma 0, so it will return me the index of the 2 comma 0. So this represents the case when we move down, and this represents the case when we move right. Okay, so after computing our new index, we have to check whether these index are in the range of the matrix, whether they are greater than equal to 0, whether they are less than equal to the number of the less than or equal to the number of the rows, and whether the column index is less than or equal to the number of the column. So nx will be compared with the n is the number of the row, and ny will be comparing with the m. And one more condition, we have to check whether the value present at the new index is 0, then only I can move in that cell, and I have to store that answer. So I will be adding that answer in one variable, and answer equal to 0, solve nx and y grid. So after solving this question, simply return the answer, and there will be one corner case. One in this question, the corner case will be, suppose I'm standing at this 0 comma 0 index, and this initially contain a rock. So in that case I cannot move in any direction, either left or right, in any direction. So for this corner case, simply I have to return 0. So I will just write this test case, obstacle grid 0 comma 0 equal to, if this is equal to 1, in that case simply return 0, else return solve 0 comma 0 obstacle grid. Pretty much we are sorted. Let's see if this code run or not. Okay, so this is giving us a time limit error, because I have added this this test case, which will give us the time limit error. If I remove this case and try to run it over the test case which are given in the question, it will pass. Okay, yeah, as you can see, it will solve the test case, and when I try to submit it, it will fail at the test case, at that large test case. So we are getting 1 TLE at the test case 30 out of the 41. So why we are getting TLE? So why we are getting TLE? First of all, we have to understand why we are getting TLE, and second, how we can overcome this TLE. So let's say you are standing at this point and you have to reach to this point, and there are some stone placed at these cells. So at one moment what you can do, you have two choices, either you can go right or either you can move down. Okay, so when you move down, these indices are wrong. 1 2 3. Okay, so when you move down from here, it will be the 1 comma 0 comma grid, and when you move right, it will be solve 0 comma 1 comma grid. And again from here you have two choices, either you can move right or either you can move left, and from here you have two choices, either you can move right or you can move move down. So if I try to move right and down from this cell. It will be first I will try to move down 2 comma 0 grid, and if I move right, solve 1 comma 1 grid, and from here if I move right, it will be solve 0 comma 2 grid, 0th row and the second column. And if I move down, it will be solve, the row index will be increased 1, column index will remain same, and grid. And from again here I can move right or down depending whether that cell contains stone or not. And from here I can again move right or down. From here I can again move right or down. But you can see at this cell we are calling this function solve 1 comma 1 grid, where 1 comma 1 is the index of the row and the column. This again is getting called in this function call, and again in this function call. So the same function call is getting called twice. So this is the reason of the TLE. We are computing this same function call again and again. So this is increasing our time complexity. So how to overcome this limitation? To overcome this limitation, what we can do, we can store the result from each call in some data structure, and later check whether we have computed that value for that function in past or not. If we have computed the same function call in the past, I will using that result, I will not recompute it again. Okay, so for memorization or for overcoming the TLE, I can use a data structure dp. The name I'm naming a dp, you can name it anything, dp, and it will be of the it will be of a 2D dp. Why 2D 2D array or matrix? Why not 3D, not a single D? Why? So the number of the parameter will depend upon the number of the parameter that are changing in your function call. In each function call there are only two parameters that are changing, that is the index of the row and the column. So that's why I am taking a 2D matrix. So, and the size of the size of this dp will depend upon the constraint limit. So here we are given the rows and the column can be up to the 100. So it is starting from the 1, so I'm taking it as 101 and 101. Initially it will contain negative value only, negative -1. This negative -1 represent that particular cell of the dp matrix is uncomputed, and if it contain any value other than the -1, means that we have computed the function for that index in the past, and we have stored the value at that index of the dp. After solving this whole function, we will be storing the result in the dp matrix, and before doing this all the computation, I have to check whether in the past I have solved this question, I have solved this function or not. If I have solved this function, this means the value of the dp should be any value other than the -1. In that case, I will be returning the value present at the dpij, because I have stored the result at that index. So when I use this approach, let me just copy and check whether when I use this approach, can I overcome the time limit error or not. Yeah, my solution is getting accepted. When I try to submit this question, let's see whether it is getting accepted or not. It is accepted. It is accepted, as you can see. Before that we were getting the TLE error. Now that you have solved this question using the recursion plus memorization approach, in the next video I will try to solve this question using tabular method. So thank you everyone.